This is part 2 of writing and naming ionic compounds. In the last video, we saw how to take the name and write the formula. And I want you to remember we did that by crisscrossing those charges. So we had to know the charges of each column of the periodic table so that we could write the cation and then the anion, write the charges and crisscross. Think about that because this is really just the opposite. We're not really undoing it, but we're just going backwards from the direction that we just went, if that makes sense. You'll see in a second. So today, what I would title this lesson, if you're taking notes, would be writing ionic names. And we're going to start with binary ionics. That means we have a metal and a nonmetal, and that's it. Remember our metal, nonmetal, cation, anion, positive, negative. It works really well because we read the periodic table from left to right like a book generally. And when we do that, you always see the metal first and the nonmetal second. The cation first and the anion second, and so on and so forth. So the name and the formula and the periodic table all move in the same order, if that makes sense. Just kind of think about that. It just works. The periodic table is just amazing. So when we write a binary compound, all we're going to do, binary ionic, is we're just going to write the cation's name first. Don't change the ending, just write literally the name of the element. Then you're going to write the name of the anion. This is where you've got to be careful, but it's so easy. You're just going to change the ending to IDE. We've already practiced that on the ion lesson. Chlorine turns into chloride. Iodine turns into iodide. Fluorine turns into fluoride, and so on and so forth, just ending in IDE. So I've got an example for you right here. NaCl is sodium chloride. I tell my students, say what you see. Sodium chloride. Also, if you want to have a little fun, you can think about what your ionic name would be. I would be Cindy Estride, maybe. So you can kind of think about that. You would only change the ending of the last name. So we're going to go ahead. We'll look at the bottom part of these notes in a second, but you may want to pause this, write this down, and then we're going to move on to some examples of binary ionics. So we're going to start right here with calcium chloride. I just gave you the answer to that. So we look at it. We know it's ionic because we see a metal and a nonmetal. So I'm going to say the name of this first. That is calcium. Write it down. And then I see the name of this, which is chlorine. We know it's going to end in IDE, so chloride. That literally is it. It's so easy. Calcium chloride. Now, I do want to point this out. A lot of kids will say, well, what about that too? Shouldn't you be saying, hey, calcium dichloride or calcium chloride 2? Shouldn't you be telling the person reading this name how many chlorines are in this? And surprisingly, for a lot of students, the answer is no, because that's the only way we can write calcium chloride. If you'll remember, if we take the name, for example, and work backwards, we know calcium is a +2. We know chlorine is a -1. And when they crisscross, we get CaCl2. That is the only way we can write this. You're not going to see Ca2Cl3, Ca4Cl10. This is it. This formula and these subscripts are completely dictated by what you had up here. Calcium always has a +2 charge. Chlorine always has a -1 charge. So when you crisscross these, that's it. That is the only way Mother Nature is going to let that happen. And because of that, when we're writing ionic names, we do not have to include these subscripts or any indication of what those subscripts were anywhere in that name. It's just understood that this calcium chloride came from this, and that's the only way it can look. Now, the reason I am really emphasizing this is because when we move on to covalence, those rules change. different set of rules for covalence. They're easy, it's just a different set of rules because it's a different game. So that said, let's continue on. If I see anything else important to point out, I may come back to that scrap paper. KBr. K is potassium. Br is bromine, which when it becomes an anion is bromide. My personal opinion here is the fact that everything ends in IDE makes things simple, because I think a lot of students, see all these chemical names before they've learned naming, and they're like, oh my gosh, how do you know I and 8 and I and all that? These all end with IDE when you're doing binary ionics. All right, let's look at the next one. This is aluminum. And that is going to be sulfide. Not dialuminum trisulfide, aluminum sulfide, because this is the only way that these two guys can hook up. Okay, moving right along. We look at this, we know it's ionic because it is a metal and a nonmetal. Left side of the periodic table, right side of the periodic table, say what you see, silver iodide. Now, if you're a beginning chemistry student and maybe this is the first time you've seen naming or you haven't been working on it that long, you may be finding like, oh my gosh, I'm struggling to keep up because I don't know what AG is. You will get better and better at that. You're going to use this so much and use that periodic table so much, things are just going to start sticking. So just stay at it, and literally within a few days, you are just unbelievably better. So don't give up. Number 5, I know it's ionic because I see a metal and a nonmetal, barium oxide. Number 6, I see a metal and a nonmetal, barium bromide. Can you believe how easy this is? I always kind of dread showing my students because at the beginning of the semester, I try to make them think maybe I'm kind of brilliant, and then they see the tricks and they're like, wow, that was real easy, and I'm not nearly as impressive. But it's a good thing it's easy. Everyone can be successful with this. Let's look at number 7. That is lithium phosphide. And the last one, number 8, sodium oxide. Say what you see, end in IDE. That is it, no prefixes. And I actually have some extra notes that you can copy down at the end that summarize all that. If you've got a little space down here, I think it would be a good idea to write down the no-no, so we know it would not be scoot that up, disodium monoxide. This is just wrong, and it's wrong because we do not use prefixes in ionics. So maybe make a note of that. You'll write it again, but that's okay. You'll remember it. Very, very important. We do not use prefixes in ionics. And again, that's the only way those are going to combine. So that's how you name binary ionic compounds. Now, because this is real simple, I'm going to go ahead and include how we work with polyatomic ions on this lesson. But before I get there, this is the North Carolina reference table packet for all of our chemistry students. If you're in another state, polyatomic ions don't change. You may not have to memorize these exact same ones, but these are very, very common. I think I actually have given my students a few extra on top of this that I just like personally using. If you do not know these polyatomic ions, I cannot stress enough to you how important it is to memorize them. Write them, say them. It will make your life so much easier. I actually give these to my students on the first day of school. They get about a month to memorize them, and then we have a quiz. I can teach my kids this lesson, and the last video I did in maybe 20 minutes in person if they know these. This is a game changer. Because when you see these in chemical formulas, you need to be able to recognize them without their charges, because once it's in a formula, the charge has already been crisscrossed out. You can look these up pretty much anywhere online. You can also go to NCDPI and look for chemistry reference table packets, and our list is there. You can find this entire reference packet. You may want to print it out so you have one at home. If you don't, it's a great resource and what most students would have in their hands anytime they take a test or quiz, or they're just doing general homework. Super, super important. In college, you may not be given these lists. When you take tests and things like that, they're probably going to expect you to have them memorized, but that is never a waste of your time, ever. So, that said, I'm going to teach this and assume you know them. If you don't, you may want to have a list in front of you before you continue this video. So now we're going to take a look at writing ionic compounds that contain polyatomic ions. And I'm only going to change one thing here. Instead of changing the second part to IDE, you're not changing anything. When you have a polyatomic ion involved in an ionic compound, you do not change the ending. Ever, ever. You just leave it as is and you say what you see. And I've got that written down on some notes that I'll put up at the end. So we just say the first one, we say the last one. So this is sodium. This is the polyatomic ion sulfate. It did have a -2 charge when it was by itself, but you can see what was a -2 here is now down here. What was a 1 here is now here. So this is just sodium sulfate. That's it. And that came from this. So we're just kind of toggling back and forth at this point. That's how we got it. That's how we got the formula. So let's look at the next one, number 2. Now, number 2 is a little different. Most of our polyatomic ions tend to be negative, but we do have some positive ones that are fairly common. Ammonium is one of those. Ammonium is NH4 plus 1. And anytime it's in an ionic compound, because it's positive, it's going to be written first. Don't let that scare you. It's just ammonium. That's it. This is ammonium nitride. Now, this is just an anion. This is just nitrogen when it takes on its -3 charge. So that's why this one is ending in IDE, because it's not a polyatomic ion. So ammonium, not ammonia, different thing, ammonium nitride. And again, this one ended with IDE because this is simply an anion. It is not a polyatomic ion. All right, next, ammonium. I see ammonium and I see phosphate. That is it. That's 2 polyatomic ions. It's a positive and a negative, so it's fine. Again, this goes back to you've got to know those polyatomic ions. If you don't know them, you're probably going to attempt something like nitrogen tetrahydride triphosphorus 4 oxide. I mean, you are just literally taking random guesses. But, and I'm going to pull this list back in here, if you know those awesome polyatomic ions, you literally just say, hey, I see ammonium and I see phosphate. Ammonium phosphate. Don't change the endings. It just is what it is. So now we've taken something that looks pretty ugly and we have really simplified it. So let's look at number 4. This is potassium and this is chlorate, the polyatomic ion chlorate. This is calcium, and this beast right here, that is hydrogen carbonate. That is a polyatomic ion. Let me see if it's on this list. Right here it is. HCO3 -1 is hydrogen carbonate. That one sometimes confuses kids because the name of the actual polyatomic ion has 2 words in it. It's okay, it's just the name of the ion. So calcium, and then the name of the polyatomic ion, hydrogen carbonate. Ooh, getting close here. Almost didn't make it. Calcium, hydrogen carbonate. All right, let's look at the next one. This is lithium, and this is hydroxide. Oh, and I'll give you a tip for some beginners. Let's say that you're having a little bit of trouble with these polyatomic ions, and when we mix all the things up, which we're going to do later, this becomes a little more important. You know, it never hurts to say, oh, I see a polyatomic ion in that one. You know, I see a polyatomic ion. And you can circle those polyatomic ions just to kind of draw your attention to it. Again, you're going to very quickly get to the point where you're just eyeballing it and you're just rattling those names off like it's nothing. But before that, you know, it just never hurts to identify those polyatomics and then write down their names. Do what works for you. All right, let's look at number 7. I've got 2 more. I'm hoping at this point you've maybe paused and just written these down and you've already tried them and now you're just seeing if you got them right. That's a great way to do it. This is magnesium, and this is the polyatomic ion bromate. And this last one, this is zinc dichromate. And I'll point that dichromate out. It's right here, Cr2O7 - 2. And just to show you where this one came from, remember that zinc had a +2 charge. Dichromate was Cr2O7 - 2. And you know what happens? Those 2's cancel, smack them together, and that's where we got the zinc dichromate. Now, if I can hunt down my notes, I'm like really accumulating a lot of paper here. Here are some more notes that you might want to copy, some things I'll point out. So just to review real quickly, when we have a binary ionic compound, if this is going from formula to name, if they give you just a binary, metal, nonmetal, you're going to write the name of the cation first, the name of the anion second, ending with IDE. Easy peasy, done. That's it. If, and I think you've already had time to copy that maybe at the beginning. If we have an ionic with a polyatomic ion, you still write the name of the cation first. If it happens to be a polyatomic ion like ammonium, that's okay, just say ammonium. Or if it's just an element, say the name. Then we write the anion, but the difference is if it's a polyatomic ion, do not change the ending ever, ever, ever of a polyatomic ion. Just write what it is, potassium and phosphate. And one last reminder, this probably doesn't mean much to you yet because some of you have not seen writing and naming covalent compounds, but we never use prefixes, and by prefixes I mean mono, di, tri, tetra, those. Never use those in ionics. That is going to come into play on the next video, which deals with covalent compounds. I hope this was helpful. I'm going to teach covalent next, then I'm going to teach the stop method with transition metals, then naming acids, and then we're going to start really having some fun because we're going to mix them all up.